Our brains evolved to count the things we could physically hold, a handful of berries, a dozen tools. We are wired to understand small, immediate quantities right in front of us, but show us a massive number, and our intuition fails. Without formatting, a sequence like this becomes noise, lacking immediate sense of value or proportion. Let's simplify and look at the foundation of large numbers, 100,000. Mathematically, it is the absolute smallest possible six-digit number you can write. But how big is it really? Is 100,000 a significant quantity, or is it actually remarkably tiny? Looking at a 1 followed by a sea of zeros doesn't answer the question. Without a physical anchor to tie those zeros to the real world, our brains have no inherent sense of their magnitude. These figures remain abstract until we apply two things: a rigid mathematical framework to organize them, and real-world examples to ground them. In the Indian place value system, the value of 100,000 has a specific defined name, 1 lakh. Measure 1 lakh in days and count backward from today, we find ourselves over 270 years in the past. Time makes 1 lakh vast. But measure distance instead. Stacking 1 lakh centimeters stretches exactly 1 kilometer, just a short walk between two city blocks. We experience cognitive dissonance because the math hasn't changed. The exact same numerical value that spans centuries of history feels trivial when applied to physical distance. This slippery relative nature of large quantities is exactly why we need a specialized mathematical system to process these numbers accurately. We cannot rely on our natural instincts for scale. We have to rely on a structured syntax that translates raw digits into reliable, understandable sizes. That syntax is built on the engine of repeated addition. Place value scales through multiplication. We start with a single unit, duplicate it by 10 to get tens, and again for hundreds. Accumulation accelerates into the thousands, filling visual space quickly. Aggregating 100 of these thousands brings us to our first lock. Now, let's bring back that chaotic string of digits from earlier, 1278830. We can test our framework on it. To make sense of it, we use commas. In mathematics, commas act as structural punctuation, grouping numbers into recognizable chunks so our brains can process them. Starting with the raw number, we apply the first comma 3 spots from the right, separating hundreds from thousands. Moving 2 more spaces left, a second comma separates thousands from lakhs, completing the Indian place value format. These commas serve as visual breath marks, organizing the digits into a readable statement, 12,78,830. Now that we have the rules in place, we can apply them to tangible reality. Take the demographic statistics of a bustling regional town. Instead of staring at an unformatted line of individuals, applying our punctuation allows us to read the town's population immediately in neat, structured lakhs. This map highlights the geographical span between two major cities in India. When measured in meters, the required number is quite high, but the commas group those meters into readable lakhs. Comparing this newly formatted distance to a familiar journey allows us to conceptualize the physical span between regions. We can apply the same logic vertically. If we map out the height of a mountain range in centimeters, the numbers stretch into the lakhs as we approach the summit. From local demographics to regional geography and vertical heights, our daily world is often described by these 6-digit quantities. The Indian place value system serves as a decoder, removing the ambiguity of 6-digit numbers and allowing us to navigate the real-world measurements we encounter every day.